All right, so here is some help if you need help on this one. Okay, which of the following circuits will have a larger current? All right, explain using Ohm's law and proportional reasoning. Okay, so circuit A, we have a 10-volt battery, okay, and a 3 ohm resistor. All right, and we're going to see what happens to the current. Okay, and a B is going to have a 10-volt battery and a 10 ohm resistor. Okay, oops, that's 5. What's wrong with my eyes? Okay, all right, so the voltage we see is going to be a 1. Okay, and the resistance has doubled. Okay, so I know just from thinking about it, if I have a higher resistance here, that's going to end up being a lower current. Okay, so V equals IR, I know that the current here was going to be 2 amps, right? So if I just set that up, okay, or I equals V over R, 10 volts over 5 ohms, I know I'm going to get 2 amps, and I want to know what happens to the current. Okay, so 1 has to equal something times 2. Okay, so I can see that that's going to have to be 1/2 because 1/2 times 2 equals 1. All right, so that's what I was looking for. So I'm going to have half the current, okay, or half of my original current of 2 amps. 1/2 times 2 is 1 amp. Okay, so I can see this is going to have been a half. Okay, written description, right? When you double the resistance and keep the same voltage, the current will halve. Like that, I think. Okay? All right, so now explain in words why this makes sense, right? So this is kind of back to the CERs. What I want you to think about is if I double the resistance, okay, doubling the resistance means it's harder to get through the circuit. Okay? Voltage is same, okay, meaning same push. Okay, therefore, it's like a little mathematical therefore, those little 3 dots. Therefore, less charges can get through. Okay, which means a lower current. Okay, so that's what I want you to explain, something like that. Okay, all right. Okay, second one. Which of the following circuits will have a larger current? This time, explain using Ohm's law and proportional reasoning. Okay, so circuit A, I have 20 volts. Okay, on a 5 ohm resistor. All right, so if I keep doing my Ohm's law again, I equals 20 over 5, which will be 4 amps. Okay, new circuit has a voltage of 10, so that's going to be a coefficient of a half, right? Because that has cut in half. Okay, my resistor this time is the same. Okay, so what's going to happen to the current? Okay, so if this is the same resistor, but now I'm halving the voltage, right? What is going to have to be here? Okay, so 1/2 is going to equal something times 1. Well, that's just going to also be a half. Okay, so here again, we see the current is going to halve, but this time it's because the voltage is halved. Okay, so when you have the voltage and the resistance is the same, okay, the current will halve. Okay, all right, so that's what I was looking for. Okay, all right, so 1/2 of the current, because that was my unknown. Okay, 1/2 of my original current, which is 4 amps. Okay, so then that means my new current is going to be 2 amps, because that's also going to be a half. Okay, right? Explain in words why this makes sense, right? So if I have the same resistance, that means the circuit is equally difficult to travel in both times. Okay, it's like the same circuit. Okay, but in B, I'm only pushing half as hard. Okay, so if I only push half as hard and the circuit is the same circuit, I'm only going to be able to get half as much charge flow, right? Because I'm only pushing half as hard. Okay, that's what I want you to say down here. Okay.